This is the agenda. I will say a few welcoming words, and then we will have a 5 minutes presentation for each project that is taking part in the session, which is DECIDO, interTwin, ExtremeXP, Crexdata, and TEMA. It will be followed by a panel debate. Next slide. So why are we all here? Why is AI important for advancing sustainability? We all know that climate change is having a tremendous impact on our economic, social, and environmental systems across the whole globe. And the consequences are expected to continue in the foreseeable future for a long time. Therefore, we need to have in place systems that help us adapt to climate change and mitigate climate change. Against this backdrop, AI has been revealed as a tool that can help us also to mitigate and adapt to climate change. How can AI technology support? We've found 4 main areas where AI can help improve this. It can help transforming raw data into actionable information. It can optimize complex systems. It can improve prediction, and it can accelerate scientific modeling and discovery. Of course, we've realized that AI is an important tool, and therefore AI is then placed into the political agenda. So there's a political recognition of AI as an important tool to fight climate change. AI is recognized as an enabler for 134 targets of the Sustainable Development Goals out of 169, and they all span across social, economic, and environmental issues. Then, zooming in a bit more in particular in Europe, AI has been recognized in the Green Deal in many other European policies as something that has the potential to contribute to European strategy to tackle environmental challenges, in particular in fostering scientific knowledge and inform and encourage responsible behavior. Zooming in again, more precisely, how is the European Union trying to support the uptake of such technologies? Is doing so through Horizon Europe projects. Investments in AI have been implemented through Horizon Europe and Digital Europe. Through these programs, the Commission is planning to invest 1 billion euros per year, which is a sum of money that makes you realize the importance that is being put on these technologies. Next slide. Now we will have the first presentation, the presentation of the DECIDO project by Konstantinos Alexakis. Please, Konstantinos, the floor is yours.
Hi all, I hope you can hear me. This is Konstantinos Alexakis, and this is the presentation for the DECIDO project. The DECIDO is an Horizon 2020 project. It started on March of 2021, and it lasts for 3 years. The main mission of the DECIDO project is to deliver a complete toolbox, including innovative methodologies, tools, and data, facilitating the policymakers to design and develop better evidence-based policies for the public sector. Next slide. The consortium consists of 14 partners. As we can see, there are many different profiles. We have policymakers, data analysts, big data experts, legal experts, etc. Now, regarding the DECIDO pilots, we have 4 pilots. The Turin pilot that deals with floods, food waste, and the Ukrainian refugees. The Greek pilot that deals with power outages in an isolated island, the island of Halki, and the Finnish and Spanish pilot that both of them deal with forest wildfires. Now, let's focus on the case of the Greek pilot, the island of Halki. As I mentioned, the island of Halki suffers from severe power outages, so there is the need for creating a mechanism for notifying the citizens in need for a potential power outage within the next 2 hours. Therefore, we developed an LSTM model that generates the probability of the likelihood of having a potential power outage within the next 2 hours. As input in this model, we used sensor data. A sustainable city has installed a sensor in the town hall of the island of Halki, and we receive the current, the voltage, and other metrics. We used this data to train the LSTM model in order to generate the probability. Then we receive that probability, and if it's higher than a threshold, the backend service returns a recommendation to send an alert. The system administrator sends an email alert. This email provides essential information procedures it needs, including safety directives, recommendations for secure locations with reliable electricity supply, the location of the health center, and directions to principal public buildings. Of course, the alerting message can be sent for scheduled power outages. And that's all from my side. Thank you for your attention.
Now we will have the second presentation of interTwin by Andrea Manzi. Please, Andrea, the floor is yours.
Thanks a lot. Good morning, everyone. I'm Andrea Manzi from the AGI Foundation. We are coordinating the interTwin project, and most of the slides are from Donatello Elia, who is working on the prototype of the digital twin on climate change extreme events projection. So the project's goal is to build a platform, a digital twin engine, which basically will has the capability to integrate with application-specific digital twins. Together with the platform, we are developing a blueprint architecture which should be interdisciplinary and co-designed with the providers and the communities. And the result platform is will be a prototype, so TRL6 or TRL7 at the end of the project in August 2025. The main feature of this is that it's co-designed, so the different digital twins application are delivering the co-designed together with the software, the technology providers, the platform, and we'll do also the validation at the end when the platform will be available. So as I said, the project is coordinated by the AGI Foundation, started more or less 1 year ago, and it brings together different type of partners, providers of infrastructure, technology providers, and the representative of communities in 5 different scientific areas. Going into the in particular for the webinar today, I'm going to describe the extreme events digital twins that we are building in the project. It's one of the use cases digital twins that we have. As you know, of course, as also introduced initially, we have climate change is leading the exacerbation of extreme events, weather events. There are different reports, of course, that are reporting about this, and this will increase in severity and frequency over the years. The next slide will show basically our approach is to use, of course, data-driven approaches in order to perform analysis of extreme weather events. This is mainly because, of course, we have now huge amounts of climate and weather data to analyze, both observation and simulations. The observation, of course, give evidence of the occurrence of extreme events once verified, but of course, we need a way also to understand how this change in the future. And of course, this can be done using data-driven models. The benefits of this is that we can train, of course, the models for prediction, and the prediction then is happening in seconds, so it's quite cost-effective. There is high accuracy, but of course the fine-tuning is quite time-consuming. And this approach is basically doesn't need the physical knowledge of the phenomena in order to build those models, because they of course taken from the huge amount of data that are trained. And this solution are quite generalizable to different geographical areas. the challenges in the next slides. Of course, we need to manage quite a big amount of data for pre-process and also augmentation of is quite time consuming. We need access to different type of computing infrastructures, cloud and HPC. And in order to have like speed up the training phase, we need a way to also automate these model workflows and to enable also reproducibility and in a fair way. This is happening thanks to what we are building this in the interTwin. So the goal is to develop a digital twins application exploiting this digital twin engine, and in particular for those use cases of extreme events which we have in the project, tropical storms and wildfire risk. The user will be able to adapt the application to different climate scenario, generate results in timely manner, and also deliver added value products for supporting new downstream services. Of course, running also what if analysis. And this is happening. So the engine that we're building now is will be able to support the integration of different heterogeneous climate and weather data from multiple sources. We have also pilots in order to integrate with different type of infrastructure, HPC and cloud. And the user will be able to support users in complex data processing and machine learning workflows in order also to track model and data provenance. And then I give you the more details on the these two digital twins that we're building. One is about tropical cyclones detections, so where we use data-driven approach convolutional graph neural networks for detecting the presence of these tropical cyclones and also track the evolution in future projection scenarios. And the other one is the wildfire danger prediction, where we use deep neural networks in order to generate wildfire danger maps. This will basically help defining the areas that are more likely to experience wildfire according to future climate scenarios. And thank you for your attention.
And now we're moving on to ExtremeXP, presentations by George Papastefanatos.
Thank you. Hello all. Welcome to this webinar. I'm George Papastefanatos. I'm the project coordinator of ExtremeXP project and the principal researcher in Athena Research Center. ExtremeXP is a Horizon project started in 2023, and it's a project gathering 20 partners, 12 academics, 5 SMEs, and 3 industrials, and has a duration of 36 months until the end of 2025. So the main vision, the main idea is for ExtremeXP is to provide accurate, precise, fit for purpose and trustworthy data-driven insights. And the goal here is to evaluate for users to evaluate different complex analytic variants, considering end users' preference and feedback. So you can consider that the user in our ExtremeXP concept, we wanted to offer a human-centered approach to AI and data-driven analytics. And for that, we consider that experimentation, this process, is the core concept for generating extremely accurate analytics. What we consider as experimentation is that the user would like to provide as input to complex analytics a user intent, some high-level goals, and the experimentation engine tries to optimize the properties of this complex analytics process. For instance, properties are the accuracy, the time to answer, the specificity, the recall, the precisions, or even the energy consumption of the analytics workflow by associating different user profile to different computation variants. The objectives of the project include the specifications and the semantics for modeling complex analytics workflows, to automate and scale out the data management for complex analytics workflows to very big and massive volumes of data, to offer a scenario-driven and opportunistic machine learning technique in the execution of AI methods, to also develop user experience and experiment-driven optimization of complex analytics, and offer transparent decision-making through interactive and explainable visualization methods, and also considering extreme data access control and knowledge management. All of these will be tested and validated, this framework, in very different application domains in real life use cases. Next. So the framework is will have as, let's say, the core idea and experimentation engine will be responsible for executing different analytic workflows. And the set of tools will surround this experimentation engines that will offer the core functionality of ExtremeXP framework, such as the transparent interactive decision-making, the knowledge management, the user-driven optimization of analytics, the analysis-aware data integration, and user-driven AutoML methods. So regarding our use cases, we have 5 use cases. 2 of them are very relevant to our webinar today. The first one aims to improve the flash flood forecasting via different AI methods. First of all, we will develop AI models that will try to hybridize the physical model that tries to reduce the need of input data, the physical model for flood forecasting. Also, we are going to develop methods for the definition of different parameters of the hydrodynamic model, given that we have a very few labeled data as input. So we are going to simulate data. We are going to augment data for defining parameters for very different models. The second use case has to do with situational intelligence and decision-making for public protection and disaster relief for fire scenarios in urban areas. We are going to develop methods to continuously monitor and detect situation characteristics from urban cameras and generate alerts based on its situations. And next, AI methods that aim at decreasing the duration of the decision-making process and mobilize responders to fire situations. Also, we are going to consider 3 other use cases regarding the flexible transportation analysis and visualization for mobility use cases, the increased cybersecurity situational awareness for efficient threat mitigations, and failure prevention in manufacturing industry. Thank you very much, and I will be very happy to share. You can find here the site and the social media links, and we'll be happy to answer any questions.
Perfect. Now let's move into Crexdata presentation by Antonios Deligiannakis.
Thank you. So my name is Antonios Deligiannakis. I'm the coordinator of the Crexdata project. Crexdata stands for Critical Action Planning over Extreme Scale Data. This is a project that started at the beginning of this year and will last for 3 years. So as you can understand from its name, Crexdata is about critical action planning. We want to be able to alert action planners about things that are going to happen in the future ahead of time. And we also want to be able to assist people that are operating on site in case of an emergency, like a flooding, a forest fire, etc. Also, because new situations may arise, we want to be able to make it easy for people to set up new data analytics workflows by using graphical user interfaces without writing any code. Also, we want to be able to support displaying accurate and trustworthy long-term forecasts and to provide visual exploratory representation supporting explainable AI. So we have several challenges at Crexdata, which involves the large variety of data. It's multilinguality. We need to be able to perform online federated learning from data from distributed sources and at limited bandwidth. We need to be able to optimize the computation of the data processing workflow across the resources that are available, etc. So the use case, the Crexdata has, if you can move to the next slide, please. Okay, so Crexdata has 3 main use cases. The weather emergency use case has 2 sub-scenarios. One involves forest fires and the other one involves pluvial flooding. It will be tested on pilots that are going to take place at Dortmund and Innsbruck. We have the health crisis use case, which also has two sub-scenarios, and the epidemic sub-scenario using epidemiological models to see how a disease may spread and how it will be impacted by different actions that we will take, like in the case of COVID-19. And the drug treatment scenario uses multi-scale mechanistic models to build the digital twin of a patient and basically to optimize the treatment of a patient based on his unique characteristics. Also, we have the maritime use case, where we want to be able to perform routing under adverse weather conditions. Now, regarding the role of artificial intelligence within Crexdata, we use AI in text mining, so when we process social media feeds. For example, we want to use ChatGPT models to both for exploring automatic labeling, also for generating synthetic data sets. We want to be able to detect fake news because we do not want to alert responders if we have some post that is not accurate. We use AI by using reinforcement learning during the optimization process. This is one of the algorithms that we are using. For the weather emergencies use case, we have started to investigate the use of neural radiance fields, or NERFs, where basically we want to build a hologram of the entire area based on the individual views that we have from drones that are flying over a scene. For the health crisis use case, we're investigating the use of machine learning in a multi-country scenario for training epidemic models. And also we're investigating the use of deep learning models for complex event forecasting. So this consortium of Crexdata and the main tasks of each partner, we are basically 16 partners working on different areas. I will not go through all of this. You can find it into our website. So thank you all. And I will look forward to taking part at the discussion later on.
And now, last but not the least, we have the presentation of TEMA by Georgios Buchagiar. I'm very sorry for butchering the surname.
Thank you very much. My name is Georgios Buchagiar. I am representing TEMA, which is for Trusted, Extremely Precise Mapping and Prediction for Emergency Management. So next slide, please. This is an Horizon project. It is recently, it started very recently, December 2022. It involves 19 partners across Europe, and this is coordinated by the Aristotle University of Thessaloniki. Next slide, please. So what is TEMA about? It aims to aid and improve natural disaster management, or NDM, for forest fires and floods. It aims to develop automated means for precise semantic mapping and phenomenon evolution predictions in real time by analyzing extreme data sources, including AI-capable autonomous devices and smart sensors at the edge, satellite images, topographical data, official meteorological data, and predictions or warnings published in the web, as well as geosocial media data, such as text, image, and video. You can see here, this illustrates how data, such as satellite images, can inform the command center, and so that authorities can intervene and save lives, save the forest, for example. Next slide, please. So TEMA objectives. The first objective is to improve and accelerate extreme data analytics. And here the first sub-goal is to increase trustworthiness of extreme data analysis algorithms. This includes speed of local and global XAI explanations. The second sub-goal is to increase accuracy of these algorithms. This includes semantic instance segmentation, object detection, and image recognition. Sub-goal number 3, to increase responsiveness and speed of these algorithms, which includes visual analysis and social media analysis speed. And the last one is to reduce latency by innovative federated data analysis on a cloud-to-edge continuum. And this includes reduced computational latency and data migration. Then the next goal is to improve and accelerate emergency phenomenon modeling, evolution prediction, simulation, and interactive visualization. Here, the first sub-objective is to increase model-based prediction, responsiveness, and speed for evolving phenomena. This includes increased dispersion model, flood model update rates. The second sub-goal is to increase model-based prediction accuracy for these phenomena, which includes fire simulation, estimated smoke plume and concentration distribution, or flood simulation. Then to improve responsiveness and interactivity of visualization mechanisms for these phenomena. Here we can have responsiveness of visualization mechanisms, content customization, increase in augmented reality immersion score. And the last one is to improve accuracy of visualization mechanisms for these phenomena, such as digital twin accuracy or merged spatial 3D map resolution increase. Then the goal number 3 is to improve natural disaster management using new digital technologies and extreme data analytics. Here, first, we need to reduce latency in natural disaster management. Second, we need to increase situational awareness in natural disaster management, reduce mental load for human operators in NDM, and prototype a proof of concept TEMA system for NDM in forest fires and floods. This illustrates the work plan. I will go into detail for each work package, technical work package, in particular 3 to 6, which is in the next slide, please. Thank you. So work package number 3 refers to trustworthy federated analytics. It includes trustworthy AI, visual data analysis, and remote sensing, geosocial media and news analysis, as well as federated analytics on an edge-to-cloud continuum. Package 4 is on predictions and decision-making. Here we have decision support service for remote sensing, information fusion, NDM phenomenon modeling, and automated response recommendations. And work package 5 is on simulation and visualization. Here we have the digital twin, geovisual analytics, and interactive visualization. Then the expected impact. First, from a scientific point of view, TEMA can assist scaling up European capacity for extreme data analytics. It can provide explainable, robust, and humanly verifiable analytics, as well as fast and precise phenomenon prediction and response planning. From a financial, economic, or technological point of view, it can aid the quantification of effectiveness, the integrated solution in realistic disaster management scenarios, as well as opening up a new market segment via the envisioned extreme analytics as a service, which can make TEMA methods available to external users through the cloud and standardized interfaces. And last, from a societal perspective, it can assist in reducing emergency response times during the management of natural disasters, improve decision-making, as well as boost the European policy agenda in the data space domain, as well as the adoption of decision support systems for emergency management. Thank you very much, and I remain at your disposal for any queries.
Thank you very much, Georgios, for your presentation and for wrapping up the presentation series we just had. Now we move on into the panel debate session. Next slide, please, in which I will ask specific questions to our speakers. Of course, they are also welcome to chip in questions that are not directly directed towards them. Participants are very welcome to provide insights and questions in the chat. And if you want to direct a specific question to a specific speaker, you can just, of course, write it in the message that you're typing and you're texting. We will be happy to direct it to the right one. Thank you. So our first question is, what are the challenges to adoption of AI for this application in your context? And I'm asking these questions to ExtremeXP and Crexdata, please. Of course, this is a broad question, so also the other speakers are welcome to chip in.
So maybe I can start. Okay, there are several challenges. Of course, I guess in all projects, we have the common thing is that we have a very large amount of data and we truly have big data. In our scenario, because we have many devices that collect data, we'll have a large number of devices. They may interact. Basically, their connection may be poor. They may disconnect at certain points, and this makes the processing of the data much challenging. We have multilingual data that we have to deal with in terms of the data from social media, and this data is also not syntactically correct all the time. We also need to handle uncertainty that can happen not only because of the data that we have from forecasting the weather, but also from other tools that we have. For example, we have a forecasting tools that tries to predict things ahead of time. So this complicates not only the processing, but also the visualization of it, especially when it comes to augmented reality, how we're going to visualize uncertainty, how we're going to visualize things about the action planners. These are basically the main things.
Yes, I can also provide some challenges on top of what Adonis previously mentioned, which are very, very also important. In our case, what we have, let's say, considering as a main challenge in our project is how we can actually take into account diverse user needs when it comes to the adoption of, and of course, the execution of AI models that aim at different goals. So you can consider that these different user needs that might pose different constraints or different high-level goals at the outcome of the AI models. For instance, a user might care about accuracy, another user might care about efficiency, about resource optimization, and so on and so forth. So these, let's say, high-level or user intents, as we call them in our project, need to be taken into account in the form of constraints in the execution, in the training, and of course in the execution of complex AI models. And of course, another crucial challenge is how we can offer accurate results, accurate outcome of AI models when the data, the input data, are not so much. So especially when it comes to critical scenarios like flood forecasting or reacting to situation of fires in urban areas, there are very few data that can be used to train our models, and so we need efficient ways to simulate, to generate data, and this also is a great challenge, especially in critical scenarios. Thank you.
Thank you very much. Now we've talked about we've discussed the challenges, and it would be interesting to hear from, so we have a very diverse set of projects here. Some of the projects have just started, some are at the middle of their work, and some others are more coming towards the end of it. So we would like to hear what are the lessons learned to ensure the supply of quality data when collecting all this data to then feed into AI. And I would like to direct these questions to Konstantinos from DECIDO and to Georgios from TEMA.
Shall I start?
Yes.
As the DECIDO project nears its completion, these are some lessons learned from collecting data from heterogeneous sources. The first one is the need for establishing data standards and data models. When we talk about different sources, the first task we have to do is to ensure the uniformity of the data. This means to standardize the units of measurements, the data format, etc. The sooner we have the data model, the better, because the development of data pipeline can be started implementing and having the first results. The uniformity in data standards is crucial, as it is not only simplifies data integration, but also enhances the accuracy and reliability of our analysis. The second one is the pre-processing of the data. In pre-processing, decisions on managing missing values and outliers are critical. They not only define our dataset integrity, but also significantly influence the outcomes and insights derived from our analysis. The last but not least is the continuously monitor the quality of data sources to promptly identify issues like defective IoT sensors in order to ensure the reliability of real-time data streams. Continuous monitoring isn't just about maintaining data quality, it's about ensuring that our real-time data streams are always reliable, which is fundamental for responsive and effective AI applications, especially in critical scenarios. These lessons from the DECIDO project underscore the complexity of data management in AI applications and pave the way for robust and effective systems for the future. Thank you.
Georgios?
Yes, of course, I would fully agree with Konstantinos. We really need well-clarified procedures on data processing to guarantee homogeneity of data, especially a way of storage. We need to make sure that all these huge amounts of data remain processable and exploitable. Just to add here that maybe also we need to inform authorities on importance of data, their value, which is not only to be used temporarily, they need to remain stored and processable for long periods of time. And also I would like to add the issue of retrievability, especially with regard to raw data and their tagging. Thank you very much.
Thank you very much, Georgios. On these past two questions, does any of the other speaker want to chip in, have something different? Do you all feel like you face the same challenges? Because that would also be important to know and to realize whether there is homogeneity in this or not. So please, the floor is yours. Thank you.
If I could add on challenges, I think one issue that we all face is the issue of authorities being unfamiliar with AI, which is pretty common in many areas.
Hello, can you hear me?
Yes.
Yes, I'm Konstantin. I work a lot with Konstantinos on the DECIDO project. We are closer to the citizen side, so I would like to add something from the citizen perspective on this. Is that exactly what Georgios said, that they can't realize exactly how AI can be useful. It was hard for them to realize that this is a model that needs to stay there and run for a lot of time so that we have useful results, while the citizens' perspective is always more practical and grounding, and they want to know how this can help them fast with practical problems that they have already experienced in the past.
Thank you very much. So now let's move to the third question that we prepared. And that question would be, how important is it to have a market and service providers for this type of AI applications? Because the European Union is investing, we are researching, we are creating these products, but then these systems and these products, these solutions have to have a life beyond the EU funding. So that's, I feel, an important question to be asked to the speakers. And I would like mainly to chip in Konstantinos from DECIDO and Georgios from TEMA, but I think this is a very important question for all the speakers. Some others, part of the speakers might have a very different perspective, such as Crexdata and ExtremeXP, as we're talking about open source solutions. So I feel like if you could chip in and provide a bit your perspective also, that would be great. Thank you. The floor is yours.
Shall I start again?
Please.
So, drawing from my experience as a researcher and R&D software engineer at National Technical University of Athens, I can say a few things about the research organizations and service providers. The research organizations, including universities, of course, are at the forefront of developing innovative AI methodologies and models. While they excel in pioneering new concepts, these institutions may face challenges in ensuring scalability and long-term sustainability of these technologies due to resource constraints and different objectives. On the other hand, the market and service providers play a critical role in addressing this gap. They bring the necessary infrastructure and financial resources to scale and commercialize AI technologies, transforming academic innovations into practical market-ready solutions. Furthermore, research organizations contribute significantly to the AI ecosystem by providing and sharing open source resources. This collaborative approach facilitates wider access to cutting-edge developments, allowing more researchers, more organizations globally to build upon these significant findings, fostering innovation and inclusivity in AI research. In a sense, the interaction between research organizations and market service providers is not just beneficial, but essential for the advancement and practical application of AI technologies.
Thank you, Konstantinos. Maybe also Andrea Manzi from interTwin would like to present a bit on this point. Thank you.
Yeah, so I can say that from the project point of view, so the GI Foundation, in the case of interTwin, is planning also to provide the platform that we are building and the digital twins that use cases that we are delivering integrated with the European Open Science Cloud, so the EOSC. So this we see that a way, to provide the platform and the services open to scientists that, of course, access the platform. And we plan also to, given that AGI is also delivering an infrastructure with the cloud and cloud resources, to provide the needed infrastructure after the end of the project as well. But of course, it is not enough. So of course, we will try to understand if these particular resources that are needed in the 200 digital twins that we are delivering could be also offered and integrated with the resources that now the EC is planning to deliver via the procurement of the EOSC nodes. So we'll try to, from one side, open the platform and the digital twins that we're developing using our own, infrastructure, but also, trying to understand if this is will be done also thanks to, let's say, implementing this with the funding from EC via the procurement of the EOSC nodes. This is basically, from the point of view of delivering what we are building to scientists via the Open Science, the European Open Science Cloud.
Thank you, Andrea. Georgios?
Yes, thank you. Just to add one remark, especially with regard to research organizations, especially universities, we can make tools, technologies, however, we miss links to the market in which we are not, of course, involved. So service providers and other actors are of particular importance, but most important, so that they can draw linkages, make this link between research organizations and the market. Thank you.
Thank you very much. Antonis, George, anything to add from your perspective?
At Crexdata, basically, I think that we have the tools that we need to do our research. Of course, we rely on some tools created by companies like ChatGPT for processing social media feeds. But we think that's really important, as Konstantinos also mentioned, to create tools that are open source. And this is why we have a commitment at the end of the project to open source our architecture and the tools that we're going to develop within Crexdata. Because we want people to be able to build on them by composing tools developed by different projects and creating newer, more novel systems. At the end, we can we can tackle the problems that we have. We do not want to have projects starting from scratch all the time. And for us, it's more important not to have a connection to the actual market, but to be able to provide the tools to other research organizations.
Thank you. That was very interesting indeed. I'm glad I picked you and asked the question. I hope the participants are happy with that as well. We have a question from the audience.
Yes. Okay.
We have a question from Gunther from Ayo Riot. Apologies if I mispronounced that. We've understood that that's not my forte today. They are a company that specializes in IoT environmental monitoring and risk assessment for natural events. And he would be interested in knowing how they can integrate AI solutions into their portfolio they offer to cities and countries. And I believe that's a good question, really, a good follow-up to the question we just asked about market and service providers. So
may I attempt to give maybe an answer to Gunther, and also have a saying on this. What I think is very important, especially when it comes to this kind of application we're discussing today, is the sharing of data, the amount of data that are available for AI techniques to be applicable in different domains. So I think for this it is important to discuss the interoperability and some standards towards the interoperability of data, and of course towards, let's say, building a data space that can actually the market can rely on for sharing not only data but also models, AI models, and of course applications that can be furthermore be part of let's say the portfolio of companies or even research service provider and research organizations. So I find very important to have let's say to work together towards some common interoperability standards for this type of data, and of course try to be as open as we can through open source software, as previous speakers mentioned before.
Thank you very much for chipping in.
If I may
any
say,
other speaker? Exactly.
Yes, if I may say a few things, because I read the chat and there was a specific mention about Crexdata. So Crexdata, basically, I did not mention it, is about basically handling streaming data, so data that are coming in and processing at that moment. So sensor data is one of the things that we may have regarding fluvial flooding. So basically measuring the level of water, but incorporating into our system should be possible, because this is what we want to do. And regarding, of course, we would like to know basically the details on basically the capabilities of the sensors, because depending on their capabilities, we may not be able to push too much computation inside. So what we do at Crexdata is basically, when we're trying to optimize the processing, we try to basically determine where each operator that does processing needs to take place, at which location, and we try to push computation at remote source. So, for example, when we try to do federated learning, we have scenarios with forest fires, like the situation that we mentioned, where we take data from drones. Drones at this moment cannot do the processing, but they transmit data to a van which operates on site. Authorities from the fire department have these vans, and then they have laptops and can do this processing. So this could be a scenario where data from your sensor network could flow into a computer at a van at that location, where basically this is an endpoint that can be integrated with the architecture. I don't know if this answers your question. I don't know if they can speak. Okay.
I'm muted. Okay, Gunther agrees and thanks you. I don't know if, Gunther, if you have any other questions, please feel free to shoot them in the chat. Now let's move to the last question, since Microsoft Teams notified us that we only have 5 minutes left. And so there's a lot of talk about making data-informed decisions and evidence-based decision-making. So this last question is quite important, I believe. What is an actionable insight? So a meaningful finding that results from analyzing the data related to data, to storytelling, data visualization, and other techniques. So in this field of AI and sustainability. And this is a question that is directly mostly to Andrea, George, and Antonis. But as usual, please, speakers, feel free to chip in at any time and to intervene on the topic.
Okay, so I can start. Well, maybe I think that this is mainly from our experience in building the digital twins in the project. We have, so for us, I think actionable insights are the ones that are triggering what is the feedback loop that digital twins should implement to the physical counterpart. So imagine that. So in manufacturing, you have like digital twins of some object or something that is being developed, and you building a digital twins is what is used then to improve the original counter components. In our case, the digital twins of the Earth, of some phenomena in the Earth, is and the output of those digital twins. It's what basically will trigger will be used in order to trigger like policymakers, politicians to understand more about climate change, and of course reduce the possibility to have extreme events in the future, and also reduce also their impact. So I think for us, the actionable insights is basically the outputs of the digital twins, and which can be used, by the the policymakers in order to improve their understanding of the output of the climate change.
Thank you, Andrea.
I can also provide a very quick, let's say, view on what is an actionable insight regarding our project, ExtremeXP. Actually, we consider that an actionable insight, especially when it comes to complex analytics workflow, is something that can be transparent, meaning that can help business mainly users, not expert or data scientists, to understand why this outcome is based on the input they had provided in their workflow. Also, it should offer explainable methods, different explainable methods, especially when it comes to complex AI methods, deep learning, or any other methods that might use, let's say, hidden layers. So this must be transparent to the user. And most importantly, it must target what the user, the main user intent. I mean, the main user's goal. So the user would like to targets, tries to find something specific. So the system must be smart enough to try to provide the right information with the most efficient way. This is what we're trying to do in our project.
Thank you.
So let me say a few things because we don't have too much time. So basically at Crexdata, we do have actionable insights, which basically have to do with if we do a classification of an event, why did we reach this classification? If we are doing, if we forecast an event that will happen, why did we reach this decision that this event will happen? We try to forecast, for example, how water is going to rise in different areas, and if it will cover certain areas like potholes, because this is important for rescuers, if it will block windows where people can exit from. And this is, of course, very relevant, not for us, not so much about storytelling, but it has to do with the visualization and mostly about augmented reality, because a lot of our techniques need to be able to assist the people that are operating on site. So they need to be able to see this information, this auxiliary information, without blocking their view. So seeing forecasts about, for example, the water and how it will rise, dangers that will happen, but also see how they can move with without being into danger, and if they get into danger, how they can get back into a safe place or where their team members are, etc. So these are all very relevant for Crexdata as well.
Thank you very much, Antonius. Anyone else wants to chip in? Otherwise, we have a question from the audience, and that will be the last one, I promise. But we started a couple of minutes later, so I think we can go further another couple of minutes if it's not a problem for anyone on the chat, on the call. Perfect. So we have Yuri Ponzani from the Escape project that asks us, especially it's a question directly to Antonius mostly. In terms of natural disasters during fires, is the data stream presented in real time, near real time? Does it need data processing for data intelligence? Because the final goal is to make it real time. And this involves both the data analytics, the federated learning, the visualization, and, oh no, sorry, that was Antonio's answer. My bad.
Yeah. So basically, I tried to reply while the other speakers were talking. So basically, yes, we're building a streaming data system. So basically, we want to be able to process data in real time. And this involves all aspects of the system, both the analytics, the federated learning, we want to be able to make it in real time, even though there may be bandwidth constraints, the visualization, things that we're going to display at operators on site. And the workflows that we are going to develop, that basically the code-free interface is basically will disseminate code into remote nodes. Basically, this is the operations and the data processing that each node will do. So basically, this is going to be in real time. We're going to support data coming in real time. The only data that will not be real time, basically the weather forecasts, will typically happen in every few hours. But the data from sensors, drones, etc., are going to be streaming in.
Does any other speaker from the panel want to chip in on this question? Or should we leave it? Do you have anything to add, anything different in your experience? I'll take that as a no. So it's time for us to wrap up. Thank you for being with us for this webinar. I hope you all enjoyed it. I found it extremely interesting to discover and to hear the explanations on how these projects are contributing in advancing targets for sustainability, and how AI can play this pivotal role in managing risk management, climate adaptation, and climate mitigation. So I would like to thank our stellar panel, and also on the background, Felipe, for his amazing organization. He was great. It's all thanks to him if we're all here. And of course, feel free to reach out to us if you need any more information on the project. You have all of our social medias and contacts here, and we are always available. Thank you very much.
Thank you all.
Thank you all.
Thank you.
Bye.
Thank you. Bye-bye.
Should we? I can't hear you. But let's call on a separate call.
Okay. Let me stop recording.